Hey everybody, it's Mr. Carr again. Today we're going to be talking about 7B Day 1, addition and subtraction of polynomials. Before we get to that, let's review some of our terms. And let's start with the word term. Okay, so we got a few new vocabulary words to go over. But I want to start with term because that is a number, variable, or multiplication of numbers and variables. Okay, this helps us define some of the other things. So a term, for example, would just be like the number 5 or 2x. Those are versions of terms. Yeah, number, variable, or multiplication of numbers and variables together. So a reminder, polynomial, excuse me, this is an algebra expression, okay, with many terms. Okay, usually if we call something a polynomial, it's got more than three terms. Okay, but we technically can call anything a polynomial as long as it's made up of terms. Monomial is going to be a polynomial with one term. So some examples of that would just be like 2x or 5, something like that. Binomial, it's in the name right there, binomial, just like a bicycle. This is a polynomial with two terms. Okay, so an example of that would be like if I did 2x plus 5. One thing to mention is that every time I add another term on, it has to be separated by addition or subtraction. So I could do something like x minus 3. This is a binomial. It has two terms. Trinomial, it's in the name again. This is a polynomial with three terms. Okay, and I can do something like this. I'll do, let's say, x squared plus 4xy minus y squared. Okay, 1, 2, 3. This still counts as a part of my terms because it's a multiplication of numbers and variables there. Okay, so once we identify whether or not something is a polynomial, we also want to identify its degree and then the leading coefficient. So the degree of a polynomial is the largest exponent or sum of exponents. Okay, we'll talk more about that, what that means when we see some examples of that one. Okay, so for example, something that is a third degree would be something like this, x to the third power. This is a third degree polynomial. So is x squared y, because that is a x to the second and then y, y to the first. We add the 2 and 1 together. That's also a third degree polynomial. Leading coefficient is the number that is multiplied by the largest degree. Okay. So for example, that if I did 2x squared plus 4x minus 5, 2 would be my leading coefficient because it's with the x squared. That's the largest degree or largest exponent in my polynomial. So a couple of rules to be polynomials. It can't have negative or negative or fractional exponents. Okay. It can't have the square root of variables. Okay. And also it can't have variables in the denominator. Okay, again, notice how I said earlier, I said it has to be for a term, a number, a variable, or multiplication of numbers and variables. Okay, if I put a variable in the denominator, now I'm doing division with that. Okay, I can actually put numbers in my denominator, that's fine, because technically I could pull it out as a fraction. Like for example, if I say x over 4, that's the same as 1/4 times x. So I'm multiplying a constant 1/4 by x. That's fine. okay? But I can't put 4 over x, okay? That leads me to some of these. So first thing is find the degree and classify it. Well, okay, so these are all examples of polynomials. So we're good here. So we just need to find the degree and classify it. So finding degree, we look at the variable with the highest exponent. In this case, it's 1. So this is a first degree. Okay, there are 2 terms because we have the subtraction sign. So there's 2 things being subtracted. So this is a binomial. So I would say a first degree binomial. Here we have 3 terms. My highest exponent is 2. So this is a second degree trinomial. Okay, x here is being raised to the first power. We have 3 halves times x. That's still a polynomial. This is a first degree monomial. Okay, after that, if I go any further than a trinomial, we just use the word polynomial. We don't worry about trying to make a 4 4 terms or 5 terms. We just do polynomial. So for example, x cubed plus 2x squared minus 4x minus 1. Okay, this would be, based on that, a third degree polynomial. All right, so standard form. Write the polynomial in standard form, identify the leading coefficient. So in standard form, we're going to put the largest degree in front. Okay, so that's what we mean by standard form. So after that, largest degree in front, and then it's in descending order. So for example here, my largest degree is 6. So I'm going to say 3x to the 6. I'm going to rewrite this. The next one would be the 2 here. So I'm going to do plus 9x squared and then minus 4x. This is my standard form here. My leading coefficient is the number 3. Okay, so leading is 3. Okay, for the second one, my largest degree is going to be the xy squared. So I'm going to take 8xy squared. The next one down will be this one with the 6xy because I have an x and a y in there. So I'm going to do minus 6xy. Then I could do plus 5y because that's just 5y, the y to the first. And then so plus 5y and then minus 12. Leading degree or leading coefficient is 8 in this case. All right, so that's our standard standard form. Put the largest degree in front, then write the rest of the terms in descending order. Adding or subtracting. You've probably seen this in the past. Let me move it down a little bit here. When you've seen this in the past, you are combining like terms. Okay, that's all we're really doing here. So for example here, I like to mark up my like terms with different symbols. For example, y squared and y squared. Okay, they'll both get underlines. Y to the y to the first power, negative 4y to the first power. And then I got negative 3 and a positive 2. Okay, so since this was addition here, everything just gets combined. So I got 7y squared and 5y squared is going to give me 12y squared. Got positive 2 and negative 4 is going to be a negative 2y. And then negative 3 and a positive 2 is a negative 1. Okay, that's it. Part B offers a slight, not a very slight extra step here. Basically, since I'm subtracting this, I am subtracting everything inside. So personally, I like to rewrite that without the parentheses, but then everything gets the opposite sign. So we're subtracting a 9y to the fourth. We are subtracting a negative 7. So that makes that a positive 7y. And then negative 2y squared and negative 10. Okay, we're taking the opposite sign of everything inside the parentheses. Now goes do the same thing. Oh, got a friend here wanting to join. So I got 6y squared, negative 2y squared. Y to the fourth is just by itself. Okay, we've got positive 8, negative 5, and positive 7. And then looks like negative 10 is by itself there. Okay, since I'm doing the standard form earlier, I'll do that again. Let's put a negative 9y to the fourth in front. Positive 6 and a positive or negative 2 is going to be a positive 4y squared. 8 minus 5 is 3. So that's 8 minus 5 is 3. And then plus 7 gives me a positive 10y. And then I finish with a negative 10. All right. All right. Example C here. Okay. Video games. The total amount of toy sales, T, in billions of dollars, consists of two groups, sales of video games, V, and sales of traditional toys, R. In recent years, the sales of traditional sales and the total sales could be represented by the following equations, where N is the number of years since 2010. Okay, so remember, R is the traditional toys, T is video games. Okay, write an equation that represents the sales of video games, V, or total amount of, sorry, hold on. So I'm going to write this down, just keep track of it. So we're saying, if I go back and kind of reread some of this, the amount of toy sales T, so that's total is T, okay, consists of two groups, V and R. So really what I'm saying is T is equal to V plus R, okay? In this part, we said we want an equation that represents V. So I'm going to do this. I'm going to subtract R to both sides so that V is equal to T minus R. That's going to help me in this step because of my two equations. So V is equal to 0.45 n cubed minus 1.85 n squared plus 4.4 n plus 22.6. So that's that's the T minus 0.46 n cubed minus 1.9 n squared plus 3n plus 19. Okay, so when it wants this equation, we are going to go ahead and just do this. Sorry, my cat is messing with everything around here because that's what cats do. All right, give me a second here. Okay, now that we're back. All right, so we want to simplify this equation now, and I want to get V as simple as possible. We get that. We're going to go ahead and combine our like terms. So we got n cubed. Oh, forgot to do this. So I'm going to treat it as plus, and then everything's going to be the opposite sign. So I got a negative here, positive here, negative here, negative here. So 0.45 n cubed, negative 0.46 n cubed. Okay, and then I've got negative 1.85 n squared, positive 1.9 n squared. We got a positive 4.4 n, negative 3 n. And then we got 22.6 and negative 19 is my two constants. So we'll put together the n cubes. I got 0.45 minus 0.46. So it's going to be a negative 0.01 n cubed. And then I have a negative 1.85 and a positive 1.9. So that's going to be a positive 0.05 n squared. Positive 4.4 minus the 3 is going to give me a positive 1.4 n. And then 22.6 minus 19, that'll give me a positive 3.6. Use the equation to predict the amount of video game sales in the year 2022. So I'm going to go back. I want to make sure I read this carefully because N is the number of years since 2010. So for example, here in the year 2010, N is 0. It's 2010 is 0 years since 2010. If I did N equals 1, that would be 2011. If I did N equals 2, that's 2012 and so on. So if I want to go all the way to 2022 to use this as a prediction, that is 12 more years compared to 2010. And that's all I need to do here. I'm going to take my V here to solve for that. I'm going to plug in 0.01 times 12 to the third power plus 0.05 times 12 squared plus 1.4 times 12 and then plus 3.6. Okay, I'm going to go ahead and just calculate that on my own calculator. So I'm going to do that. I'll pause first real fast. Okay, and so I get 10.32 as my answer for V here. And so remember, V represents just, what does it say? Sales of video games. In billions of dollars. Okay, so we're saying that V is equal to $10.32 billion. And that's just from video games. Okay, so again, we kind of went through a lot today. Make sure you kind of understand what we mean by these terms. We use them in class, you'll see them on homework. Polynomial is just all the monomial, binomial, they all fall under the name polynomial. Okay, but monomial is just one term, binomial is two terms, trinomial is three terms. Okay, we're talking about degree and leading coefficient. We get the leading coefficient by writing in order first. Okay, what makes a polynomial, things like that, and then first degree, second degree, things like that. Okay, and then also binomial, trinomial there, identifying those ideas. Okay, adding, subtracting is probably the other big main idea, making sure we understand how to do that. We are combining like terms. We are only like terms if it matches up exactly with the variable and degree. So for example, that's why I was put y squareds with y squares and y squareds together. Okay, y to the fourth. Oh, I missed that from earlier. My bad. Let me go fix this one right now. Since we're already here reviewing it, that was supposed to be y to the fourth. And so that means that is not one of those. Okay, so y to the fourth. Okay, so 6y squared minus 2y squared, or sorry, 8 minus 9, so it's a negative y to the fourth. And then 6y squared minus 2y squared is a positive 4y squared. Negative 5, 5y and positive 7 is going to be a positive 2y. And then I just have the negative 10 for my constant, and that's it. Whoops. Okay, well, all right, fix that. Bottom line is we have y to the fourth going together with another y to the fourth. Make sure they match up by variables and degrees. Okay, that's it for 7B day 1. Take care, everybody.